Hey guys, and welcome to this video on graphing relationships. So let's make it happen. Alright, now that we know how to create equations to represent real-world situations, let's go ahead and practice representing these relationships visually with a graph. Now, here are some of my guidelines for graphing. First things first, before we do anything, let's give our graph a title. Once you have your equation and know what your dependent and independent quantities are, then let's label the axes. Remember, the dependent variable most of the time goes on the vertical axis, and the independent variable most of the time goes on the horizontal axis. And please make sure to label the axes with both the quantity and the variable that represents it. Then I suggest creating a table of values with a whole bunch of ordered pairs for the quantities in question. Now that you have your table of values, let's determine what an appropriate scale would be for each box on each set of axes. So for instance, on our horizontal axis, let's let 2 boxes represent 1 month. And on our vertical axis, let's let 2 boxes represent 20 followers, or 1 box represents 10 followers. Also, you want to determine where each quantity is going to start. Note that both of these quantities, neither of them have to start at 0 at the beginning of the axis. But in this case, I think it would be a good idea to have them start at 0. Couple of quick notes. It would be kind of inconvenient and cumbersome to label every single notch all the way down your axes. So what I tend to do is label the first few so the reader gets an idea for how much every box is worth, and then I label only the major ones out at the end. Also note, it's really important down here in the lower left-hand corner to explicitly indicate where each of your quantities is starting. Even if it's 0, it's really important to show here that the independent quantity is starting at 0, and here that the dependent quantity is starting at 0, especially if it's something not 0. You want to make that real clear to the reader. At this point, it's time to graph the ordered pairs from our table of values. At this point, we can extrapolate that the ordered pairs probably continue on in this fashion, so let's go draw some more. Next, we decide whether our graph should be discrete or continuous. In this case, this relationship would best be described with a discrete graph, so we're not going to go ahead and connect those points. If it were best described with a continuous graph, we would. And the last thing, once your graph is drawn, it's helpful to label it with the equation that you made earlier. Now note, we can make the scale on either axis whatever we want. For instance, on our vertical axis, instead of having each 1 box representing 10 followers, we could have had every 1 box representing 20 followers. And while this graph may look a little different, it actually captures the exact same relationship. I'm going to take this a step farther and use a graphing calculator app on the iPad to show you how different graphs with different scales can all capture the exact same relationship. Alright, here's a graph of that relationship we were just discussing, and the axes right now are scaled so it looks like almost more or less a 45-degree line. Very nice. But note that if I change the scale on the vertical axis, that's the exact same information, but of course it looks a lot different. I also could have changed the scale on the vertical axis the other way. Making the line seem much steeper when it's actually the exact same information as before. So always a good idea to be very cognizant of the scale on your axes because the graph you're looking at can be quite misleading. Here's an example. Here's a graph of some interest rates in the United States in the years 2008, 2009, 2010, 2011, and 2012. Really makes it look like interest rates were going up pretty quickly through those years. But if you take a look at the scale on the left, the bottom of the graph is at 3.140%, and the top of the graph is at 3.154%. So while it looks like it's a big change, that actually isn't much of a change at all. And here's another graph of the exact same interest rates, just with a different scale. And look how similar the interest rates look now. Just changing that scale on the vertical axis completely changed what the graph looked like and what information you might initially draw from it. Alright, let's do another one. After being posted to YouTube on October 5th, and of course starting with 0 views, a viral video finishes each day with 10,000 more views. Alright, first things first, let's title our graph. Let's go ahead and define our variables. Now already, if we let our dependent variable be just the number of views, we know we're going to have to write 10,000 and 20,000 and 30,000 and 40,000 on all these little notches on our graph. So this is a great opportunity to define this variable as the number of views in thousands. That way we can just write 10, 20, 30 instead of 10,000, 20,000, 30,000. All right, let's create a table of values. Let's create an equation, and then we'll reconvene to talk about the scale and the range on our axes. All right, now that we got our table of values and our equation, it's time to label our axes and decide on a scale. So we see that on our horizontal axis for months, so let's definitely start at 0. And we want to end up at about 5. So let's make every 4 boxes equal to 1 month. Note, you don't have to draw what every single one box represents. You'd have all sorts of fractions and stuff. This is totally enough info for the reader. For our vertical axis, the first thing I should say is that I should have labeled it as views in thousands. If you're going to define your variable creatively in this way, you definitely have to let the reader know by labeling your axis accordingly. So I'm going to redo my vertical label just so it says in thousands, so it's really clear to the reader. Please do so yourself as well. Alright, now we're ready to make a scale. Again, we're going to want to start at 0. If I wanted to make my scales exactly the same, I'd go from 0 on the bottom to 50,000 on the top. But just to mix things up so we're not doing the exact same scale every time, let's just make it 3 boxes equals 10,000 views. Alright, now that we've got our labels, now that we've got our scale, it's time to graph these ordered pairs. Once again, this relationship is best described as a discrete graph, so I'm not going to connect these points. And now that we're done graphing, let's go ahead and label it with our equation. One thing I really like about this graph is that note that every single day that goes by, the number of YouTube views goes up by the same amount, 10,000. Now, quick question. How would the equation change and how would the graph change if that video received 20,000 views each day instead of 10,000 views? Our equation would change to b equals 20 times n. You can see how the table of values changed, and of course the ordered pairs on our graph changed as well. In fact, the graph is twice as steep. Now note, maybe you used the same scale I did, maybe you used a different scale, but whatever scale you used, that graph is going to be twice as steep now. For every 1 day that goes by, the number of views goes up by 20,000. Alright, let's practice with a few more examples. On February 7th, you purchased a new car with 0 miles on the odometer. Since then, you drive it consistently throughout each month, and you put on 2,000 more miles over the course of each month. So let's go ahead and title our graph, define our variables, make an equation, label our axes, and create a table of values, and then we'll reconvene to decide on a scale and range for our axes. Alright, now that we have our equation and we've got our table of values to work from, let's make our horizontal axis go from 0 to 5. And let's make our vertical axis go from 0 to 10,000. And now we're ready to graph our ordered pairs. In this case, the relationship would best be described by a continuous graph, so let's go ahead and connect our ordered pairs. And last but not least, let's label our graph with its equation. Once again, I love how this graph visually shows that every 1 month that goes by, the number of miles on the car goes up by the exact same amount, namely 2,000 miles. Quick question, how would our equation change and how would our graph change if over the course of each month we drove the car only 1,000 miles? So the first thing we notice is that our equation has changed from d equals 0 plus 2,000 times n to d equals 0 plus 1,000 times n. Of course, because we're going only 1,000 miles each month. The table of values changed, the ordered pairs changed, and you can see that since we're driving only half as far every month, this second line in orange is only half as steep as this line in red. That every 1 month that goes by, we are now only traveling 1,000 miles. Alright, let's do another example, and this one's going to be slightly different from the ones we've done already. On January 16th, you already had 100 Twitter followers. Since then, every month you gain 20 more Twitter followers. So I'm going to have you title your graph, define your variables, label your axes, create some ordered pairs, make an equation, and then we'll reconvene to talk about scale and range on our axes. Alright, so I think the most appropriate scale is going to be to make 2 boxes on our horizontal axis equal to 1 month, and 2 boxes on our vertical axis to be equal to 20 followers. Now the question is where to start. For now, let's go ahead and start both our horizontal axis and our vertical axis at 0. Now that we have our scale, time to graph our ordered pairs. And note that for the first time, we are not going to have an ordered pair in our bottom left-hand corner at the point 0, 0. We're going to start with our first ordered pair at 0, 100. Once again, this relationship is best described with a discrete graph, so we won't connect them. And you can see that this point right here tells us that on January 16th, 0 months since January 16th, we started with 100 followers. And of course, every month that went by, the number of followers we had went up by 20. Now note, our axes do not need to begin at the value 0. They can start at whatever value we'd like. However, it's really important to mark this value with a dash on the appropriate axis. So what if we took our vertical axis and instead of starting it at 0, we started it at 100? Now when we graph our ordered pairs, we can fit a whole lot more of them on the graph, and some might believe that this graph is a little easier to read and might be more informative. So again, remember, you can make that starting value on whichever axis whenever you'd like. You just have to make it very clear to the reader. Here we have one axis, our horizontal axis, starting at 0, and the other one not starting at 0. That's totally fine. More often than not, it's going to be totally fine to start our independent axis at 0, but oftentimes our dependent axis starting it at 0 would make the graph really hard to draw, so we're going to need to start it somewhere other than 0. And a really great candidate for where to start your dependent axis is if you look at your table of values and just find the smallest number that your dependent quantity ever takes on, and that's a great place to start your vertical axis. Alright guys, that's it for this video. I hope you enjoyed and I hope you found it helpful.